Welcome to this module on vector databases. Throughout this module, we will delve deeper into vector databases, which allow us to enhance large language models with additional knowledge. There are two main ways in which large language models can be used. One is through fine-tuning during training, and the other is through the model's inputs. In model training, also known as fine-tuning, we adjust the weights of the model. The more recent method involves model engineering, also known as the model phase. The other more recent approach involves prompt engineering, where we add information and context to the prompt, and this is done through the inputs. We pass knowledge directly to the model in the prompt and incorporate it as context in the model's responses. Fine-tuning is useful for specialized tasks, while providing context allows for more precision and enables the use of knowledge in the responses. However, OpenAI's GPT-3 model has a limitation in terms of the character length it accepts in the context, which is 4,000 tokens. This isn't very long considering the length of most documents. One solution would be to pass summaries of the documents or break them down into smaller chunks. Anthropic has developed a model called Cloud, which can handle up to 100,000 tokens per context, but this incurs a higher cost and also requires more processing time. Although increasing the context length helps the model acquire more information, new model architectures and solutions are needed to address context-related challenges more effectively. One effective way to pass knowledge to the model is through vector databases. Starting from a large corpus of knowledge, we would break it down into different fragments, transform these into embeddings, and then orderly store them through a semantic index in a vector database. This vector database allows us to perform a semantic search for the most relevant information fragment to answer the user's question. Thanks to this system, the model could utilize relevant knowledge in its responses without the need for a fine-tuning process or an increase in the token capacity that the model accepts in the input. This is why vector databases have gained significant relevance in recent months, with more advanced and efficient vector databases being developed. How have these vector databases been developed? Initially, we started with traditional databases, which were relational databases queried through SQL. They were designed for structured data and depended on fixed schemas. We then moved towards unstructured databases, the NoSQL databases, which offer greater flexibility in handling unstructured or semi-structured data. Finally, in the latest development phase, vector databases were developed. These vector databases provide an optimized solution for managing and querying high-dimensional vector data, i.e., data fragments transformed or derived from texts. These types of vectors are, in fact, what large language models use to work with texts.